16 students and 24 enrolled. Hopefully we're not going to successfully lose people for the semester, but I guess I did make attendance not mandatory, so. But does anybody have any questions about anything before we start? Okay, so this is where we left off. We're in chapter 3, and we're starting to get into molecular or the chemical accounting. And so if you remember in the beginning of the semester, I talked about mixtures. You can take mixtures and break them apart into pure substances. Well, pure substances can be elements or compounds. And elements can be atomic or molecular. Not also included metallic. Metallic would probably be atomic then. And compounds can either be molecular, where they share electrons, or ionic, where one element transfers electrons to the other. So, and the difference, which we'll get into more, especially with the covalent, with the molecules in chapters 9, 10, 11. Okay, so here's an example of a molecule, propane. I just grilled some steak last night and used my good old propane grill. That's a molecule. Definition of a molecule is a stable group of atoms. So think of a stable couple. What's a stable couple like? They're always hanging out together. What's an unstable couple like? Well, they come together, they fight, and they break apart, right? So a stable molecule is one that sticks together, just like a stable couple. An unstable molecule is explosive. It literally is explosive. It breaks apart and releases a bunch of energy, just like a explosive relationship, unstable couple you'd think in like a dramatic thing. And ionic compound, so like sodium chloride salt, the one atom gives electrons to the other atom, atoms are atom, and then they bound together by unlike charges. And let's classify some of them. What is this? So looking at this on the right, this is looking at these atoms. This is a group of atoms together forming a molecule. This is a covalent bond. So this is a molecular element, and the atoms are all the same. So let's look at a couple of these. Classify these as atomic element, molecular compound, or ionic compound. So as far as which elements are just going to be by themselves, noble gases are one. Xenon is a noble gas. So, and it, oops, I was watching movies yesterday. So, noble gases, all these here, they're going to exist as atomic elements. All of these other nonmetals, they all exist as molecules, 2 or more. Sulfur and phosphorus, they can form more than diatomics. Actually, you usually don't get diatomic phosphorus you can get diatomic sulfur, but it's very unstable. Tend to have at least 6 sulfurs. Carbon can do all sorts of things. Can form graphite, can form diamond, can form these clusters of C60 or C70 called fullerenes. So carbon makes many, a whole network. These would all be metallic, to metallic bonding. The metalloids, the semiconductors, they tend to form molecular solids. So kind of like a diamond or graphite. So similar to carbon in that. So xenon, it's a noble gas, it's just by itself. This one, I guess I can highlight. Atomic elements. Xenon is an atomic element. Molecular element. Molecular compound. Ionic compound. Okay, so the next one, and if you can't see the colors, nickel chloride, this is a metal and a non-metal. That's ionic compound. And I'm highlighting bromine. Bromine is a non-metal. It forms a molecular element. NO2, These are a combination of nonmetals. It forms what? Sorry. This forms like a compound. Is that the same color? You can see it's the same. Yeah. That forms a molecular compound. And sodium nitrate, the next one there, E. This is a metal and a group of nonmetals called a polyatomic ion. We haven't covered that yet. This is an ionic compound. So, okay. Next thing is naming. Are we doing some more questions? Okay. Naming. So when we name, you can see I've used the names of things quite a bit. I do it without even thinking. So the first type is to name something that has a metal and a nonmetal, and there's only one type of ion. So meaning like the alkalis, the alkaline earths that only have one type of cation. Cation is the positive one. The T, the cat and positive is, or T, the T is positive and cation. So when you name just a binary, two elements, you say the name of the metal, and then you say the root name of the nonmetal plus IDE. So these are the elements calcium and bromine. So you say the whole name of the metal, calcium, and bromine, he shorted to brom, and then plus IDE, calcium bromide. And saying calcium bromide, you imply that you think the calcium is a +2 ion, because calcium is an alkaline earth. It's +2, the second column over. And what about things with more than one charge? When you say that, same idea, say the name of the metal, and then in speaking, you say the number. In writing, you put the number of the charge in Roman numerals, and then the same base name of the anion plus IDE. So, for instance, this one here, PbCl4. And you can see another thing, there's some colloquial ways of doing it as a chemist, and saying PbCl4 is another one, although it's not proper. So, but PbCl4. Chlorine forms -1 ion, and the -1 forces the lead to be +4. So when you do that, forces the lead to be +4. And you say for this, lead 4 chloride. Lead can also be +2. Lead can be +2 or +4. So here are some metals that have multiple charges. And this is something you do not have to memorize. This is something you'll be given. So, I mean, again, remember, 20 years from now, are you going to be happy that you remember that copper has +1 and +2? Is that really, that important? I think I want you to focus on learning this stuff. The caveat with that, though, is I will give you all the stuff, but if you go on and you take like the MCATs or the GRE in chemistry or something like that, you will be expected to know all this stuff. So they give you much less. They'll give you a periodic table. That's about it. So, but I'd rather you as a student right now focus on learning the concepts, and some of this stuff, the memorization stuff, you don't have to. This cuprous and cupric, like you can see the older name, no one really uses that anymore. At least no one that doesn't have a beard like ZZ Top, So someone else might say that. And well, here's an old chemistry joke. So that's one thing about being a chemist, is that the humor is pretty terrible. Can anyone guess what I'm drawing here? It's a Ferris wheel. Oh, don't you love chemistry humor? Okay. Of course, we don't really use that anymore. So, okay. So naming compounds, two elements. If it's only one charge, you just say the metal plus the root of the anion plus IDE. For multiple ions, you include the number, and in Roman numerals. Here are some Roman numerals. Things really don't go past 7. There's a +7 ion for manganese, but really having a very positive charge doesn't happen very frequently. So if you just remember, up to 7, you should be fine. But Roman numerals, I is 1, V is 5, X is 10, L is 50, C is 100, M is 1,000. And if you have a lower number before a bigger number, it's the bigger number minus the lower number. If you have a lower number after the bigger number, it's the bigger number plus the number. So 1 is I, 2 is II, 3 is III, 4 is IV, 1 less than 5. 5 is V, 6 is VI, 5 plus 1, 7 is VII, and so on. And 9 is IX, 1 less than 10. 11 is XI. So, but we typically don't use Roman numerals in general, except for sometimes you see them on the side of buildings. Like if you see MMXIII, that means 2008. That means the building was built in 2008. We tend to use Arabic numerals, which is our like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Those are Arabic numerals. Okay. Another thing you do not have to memorize, which will be given to you, polyatomic ions. So if you are in a monogamous relationship, how many people are you in a relationship with? 1. If you are a polygamist, how many people are you in a relationship with? Yeah, 2 or more, right? So if it's a monatomic ion, how many atoms are there? 1. If it's a polyatomic ion, how many atoms are there? 2 or more. Yes, there are some that involve 2 atoms only. Peroxide, for instance, and hydroxide. Is hydroxide? Yeah, hydroxide here. Those are just 2. But here you have like acetate up top. That's 7. So, and it's a group of 7 atoms all hang out together. And that whole group of atoms has a -1 charge. All right, so now let's go on to talk about molecular compounds. So molecular compounds, you say a prefix, the name of the first element, prefix, name of the second element, plus IDE. So just like the metals and nonmetals, you say the full element first name. If there's only one of the first elements, you do not include the prefix. So an example, a couple of these, like CO and CO2. So by these rules, there's 1 carbon, so you say monocarbon, oxygen, oxide. So monocarbon, monoxide, we drop the mono, so this is just carbon monoxide. And the same thing with this, you drop the mono, carbon di for 2, carbon dioxide. And of course, we have certain elements that have common names, like NH3. We don't call it nitrogen trihydride, we call it ammonia. And water, like the first day of class, we call it water, we don't call it dihydrogen monoxide. And there are some common names that are not really proper, but we still use them. They sound scientific. Acetic, like acetic acid, is actually a common name. The real proper name is ethanoic acid for 2 carbons, ethanol. Another one, vitamin C. Vitamin C is the common name for ascorbic acid. Ascorbic acid is a common name. I don't know what ascorbic acid's official name is. Ascorbic means anti-scurvy acid. If you eat this acid, you don't get scurvy. So that's what ascorbic means, anti-scurvy acid. So it has another name. I don't know what it is. So, but it's amazing how you can have layers of common names and really, really proper names. Okay, so let's name each of these. Ni3, so nitrogen and 3 iodines. So you name the entire element for the first one. So you say nitrogen, and then the tri, then iodine, iodide. I can tell you that if you put this into a spell checker, it's going to be angry with you. So spell checkers on Microsoft Office do not like it when you name molecular compounds. They'll tell you there's something wrong. There's also 2 I's in there too, which is relatively rare for the English language. Okay, next one. This is phosphorus and 5 chlorides. This is phosphorus pentachloride. So I think it's, how do you spell phosphorus? I always misspell phosphorus.
Phosphorus.
O-R-U-S, yes. Phosphorus and pentachloride. So penta is 5. And the next one is P4S10. So it's not 1 in the beginning, so we have to include the prefix. This is tetraphosphorus decasulfide. How'd you like that for a spelling bee contest right there? All right. So how are we doing? Questions with this? I know this stuff is, we're still just naming things. Just like Romeo and Juliet, what's in a name? Would a rose smell as sweet if it were called by a different name? Would hydrochloric acid still burn if it was called something else? I guess it is called something. It's muriatic acid. Muriatic acid burn is bad. So now we're going to move on and talk about acids. For binary acids, so how many elements are in binary acids? 2. Binary, bi means 2. So hydro, base name of the nonmetal, plus ic acid. So the base name of the nonmetal, like chlorine, so chlorine, chloric. So HCl, that's hydrochloric acid. So you say that word. It's HCl is hydrochloric acid. And then the next part is oxyacids. And what is an oxyacid? It's an acid that has oxygen in it. And oxyanions that end in 8, you say base name of the oxyanion plus ic acid. If the oxyanion ends with ite, you say the base name of the oxyanion plus us, then acid. So just to confuse you even more, there is no convention over what is an ate and an ite oxyanion. So to give you an example, nitrate is NO3. So nitrate is NO3, sulfate is SO4. So you can see the number of oxygens is not consistent. So nitrate is NO3, nitrite is NO2. So HNO3 is the 8 nitrate. This is nitric acid. And nitrite, NO2, so HNO2 is nitrous acid. So, and the book doesn't go into this, but if you There's some other cases. So ClO3, that's chlorate. So HCl3 is chloric acid. ClO2 is chlorite. This is chlorous acid. If you have an extra oxygen past the 8, so chlorate plus another oxygen, you put the word per in front of that. So if this is chlorate, this is perchlorate, which is perchloric acid then with the hydrogen. And chlorite is ClO2. If you take away an oxygen, you call it hypo. So this is hypochlorite. And with an H, this is hypochlorous acid. So bleach, I love bleach. I put bleach on everything, except for my colors and my laundry. But bleach is NaClO. It's sodium hypochlorite. So add a hydrogen to it. This is then hypochlorous acid. And the H is what makes it an acid. We're going to cover acids a little bit in chapter 5, very so slightly, cover it much more in depth in Chemistry 162. So, all right, so here is our summary of how to name things. And this is, I usually photocopy this and put it on your first test. So, but it is important to know how to name things, but I give you a head start on this. So for ionic compounds, if the metal only has one ion, you put the name of the metal and then the base of the anion plus IDE. So here the example, calcium iodide, calcium and iodine, so calcium iodide. Should I pose for the picture? For more than one type of ion, same idea, but you put the number. You say the number, you put it in Roman numerals. So iron can be +2 or +3. You say iron 3 chloride. You don't say ferrous for +2 or ferric for +3 anymore. And typically speaking, like honestly, I don't know the difference. So, and I have a PhD in chemistry. For molecular compounds that have only nonmetals, you have the prefix, name of the first element. Unless it's 1, then you drop the mono. Prefix, name of the second element, or base name of the second element plus IDE. So P2O5, diphosphorus pentaoxide. Di for the 2 for the phosphorus, penta for the oxygen, oxide to short plus the short base plus IDE. So for acids, binary acids, 2 elements, hydro, base name of the nonmetal plus ic plus acid. So HCl, hydrochloric acid, HI, hydroiodic acid, HF, hydrofluoric acid, and so on. Oxyacids, if it's 8, so sulfate, then it's plus ic, sulfuric acid. If it's ite, if it's sulfite, you put us. Sulfite is sulfurous acid. Makes sense? And you'll be given, and I also allow questions during tests. So if there's something that you don't know, you're allowed to ask. I guess I should mention the common name. So, most people use the common name. So, do we have bisphosphonate? Oh, I guess we don't have that. Most of the time we say bi. So, bi can mean a couple things. Bi can mean 2. Bi can also mean an extra hydrogen. So, soda. Soda is CO3, sorry. Like washing soda is sodium carbonate. So soda is CO3. And the bicarbonate of soda, sometimes referred to as sodium bicarbonate, also known as baking soda. That is HCO3. So bi can mean an extra H as well. So if you see something like bisulfide or bisulfate, that means the bi means a hydrogen. And that is a common name, not a formal name as well. All these rules. You thought chemistry was going to be easy. There's so many rules. But they all kind of make sense in a way if you do it long enough. It makes you feel better. Questions so far? Okay. So now let's talk about calculating formula masses. So we've already talked about moles. So and we talked about moles with elements, but we're talking about compounds now. How do we deal with moles of elements? So compounds. Moles of elements are easy. You look at the periodic table and you just use the atomic weight. What about groups of atoms, stable groups of atoms, also known as molecules? So how we figure out the formula mass for that, you have the number of elements in the first element times the atomic mass of that element plus the number of atoms of the second element times the atomic mass, and you sum them up. So let's do this for glucose. So glucose, calculate the formula mass for glucose, C6H12O6. So the subscripts here, so when you see C6H12O6, the subscripts means that there are 6 carbons, 12 hydrogens, and 6 oxygens. So those subscripts mean the number of each of those elements. And if you already know that, I'm sorry. I'm just making sure that everyone knows what we're on the same page. So the formula mass for glucose, this is going to be, I'll do the bigger pen. So 6 times the molecular weight for carbon plus 12 times the molecular weight for hydrogen, or the atomic mass for hydrogen, plus 6 times the molecular weight for oxygen. I'm doing OX because my O and 0 are really just the same thing. So, and I'm getting this 6 from here, this 12 from here, this 6 from there. And then you put the numbers in from the periodic table, which you will be given. You never have to memorize this. 6 times 12.01 for carbon plus 12 times 1.008 plus 6 times 16 for oxygen. And I know it's 180. That's just something I have. A couple of these I have memorized. I know that, what is it exactly? I could throw up the calculator. But I know glucose is 180, but what is the fraction? Fraction, it's 180.16. 180.16 AMU or grams per mole, like that. So, okay, so recap with this. We're figuring out the formula mass. Take the number of each element times the atomic mass of each, and you sum them together. For glucose, we use 6 carbons, 12 hydrogens, 6 oxygens. We get the atomic mass from the periodic table, and we sum them up, and we get 180. Questions with this? Okay. So let's do this then, and then now let's figure out, do some calculations. So an aspirin tablet contains 325 milligrams of acetylsalicylic acid. Also, that is aspirin, acetylsalicylic acid. How many acetylsalicylic acid molecules does it contain? So I'll follow the, I think the book. I think do they divide that out? They probably do that. I'll follow the book. what I would do, I would just go ahead and write 0.325 grams and be done with it. But I'll follow the book so it doesn't confuse you. So we have 325 milligrams, and I just say, it's not arsenic, it's aspirin. I'll get rid of the S. Milligram. So then there is a gram aspirin to 1,000 milligrams aspirin. And then we have to figure out the molecular mass of acetylsalicylic acid. It's also 180 just by chance. It's 180.15. So 9 times 12.01 plus 8 times 1.008 plus 4 times 16 is 180.15. That's just not everything is 180 grams per mole. That's just the luck there. So okay, so then we have a mole of aspirin to 180.15 grams of aspirin, and then amongst molecules, then use Avogadro's number 6.02 times 10 to the 23rd A molecules per mole aspirin. So if you look at the units, again, units, milligrams cancel, grams cancel, moles cancel, left with what we want, aspirin molecules. And what is this? This is going to be 1.09 times 10 to the 21st aspirin molecules. And when you put this in your calculator, let me see if I can do this in my calculator. I wonder if it'll show. 0.325 divided by 180. Okay. Oop. Man, I'm getting an ad for my free phone, or not free phone, free app. Okay, so it depends on your calculator. Oh, I should zoom in. So what I did, I just went ahead and put 0.325. I skipped the 1,000 step. I just combined that. And so you can see I put 0.325 divided by 180 times Avogadro's number. And in my calculator, there's this EXP, this exponent function. Some calculators, it has this E. Oop, that's too many. What letter is that? There's this EE button. The EE button is the same thing. So it depends on your calculator. Like I said, this is a free one that I downloaded because I'm cheap, right? So it just depends on your calculator. And use those buttons rather than doing times 10 to the whatever. That'll save you so much time. Okay. Have we done some more questions? So finally, you guys get to do some calculations. Aren't you excited? Okay, as promised, I'm going to give you a problem now, and now you can calculate stuff. I know you can, I'm tired of hearing myself talk. I don't know how you guys. So similar problem. So aspirin does in fact have 325 milligrams. Ibuprofen, the standard dose is 200 milligrams. I know it's got other stuff like the liquid gel. I usually do the liquid gels and other stuff in it, but how many ibuprofen molecules? Ibuprofen is C13H18O2 in a 200 milligram tablet. So why don't you take a few minutes to try and solve that, and then I will take an initial vote and see how you're doing. If everyone gets it, then we move on. If you're having trouble, I'm going to come around and talk to people, and you can also work in small groups. So give it a whirl right now. Oh, and I should tell you, carbon's going to be 12 grams per mole. Hydrogen is 1 gram per mole. Oxygen is 16 grams per mole. Another question is, how do I know how many digits to go through the periodic table? Depends on how many sig figs you have. 325 milligrams, you have 3 sig figs. So you don't even have to go to 180.15. You can go to 180. It's more proper to go put more digits than round at the end, but it works. It's the truncation error. All right, how many people think A? It's 5.8 times 10 to the 23. I think B. I think C. I think D. Okay. Is anybody completely lost, so has no idea what the heck's going on? Raise your hand. Okay. All righty. So you can work by yourself, or you can, like, you 3 or you 4, or you guys can talk, or you 2 or you 4, huddle up and help each other out. So, but I'm going to come around. Sorry about that.
The most lost person?
So who lost?
Okay. I don't do this. I'm very adept at conversion, so
Okay.
I don't know if we're going to
Do you understand how this works?
a little bit. You
Okay.
went through it pretty fast, but I got it.
Okay. So this aspirin has 325 milligrams of this stuff. How many molecules? So this here is just mass converted to grams. Do you see, like, with the units converting between moles and mass?
Yeah.
So
I got it when you were doing it, but if I were to just look at that, it wouldn't be anything to me.
yeah, you're multiplied by 1 a bunch of times. Like, how many seconds are there in a year? There's 365 days in a year. There's 24 hours in a day.
Mm-hmm.
There's 60 minutes in an hour and 60 seconds. You're just multiplying by 1 over and over again, right?
Right.
So this is what we're doing. We're taking 325. There is a gram and 1,000 milligrams. A mole of aspirin is 180 grams of aspirin. 6.02 times 10 to the 23rd is a mole,
Mm-hmm.
right? So you're multiplying by 1, and the units all cancel.
Okay.
Right? So do you understand that?
Mm-hmm.
So you have to do the same thing for ibuprofen.
Okay.
So
we just set it up with like the 200 here.
yeah,
Okay.
1,000.
Mm-hmm.
And then the thing is, you have to calculate the molecular mass. Do you know how to do the molecular mass of this?
I guess not.
So it is 13 times 12 plus 18 times 1 plus 2 times 16.
Is that what we did here?
Yeah.
So the answer is yes, I do.
Yeah. No, you're putting it together. This takes time.
Okay, so we were going to do just like this example here that we did for the glucose.
Yeah.
Okay. So that's going to look 16.
Oh, well, I guess. Yeah, this is 206. That's the. So you already have finished that. That's cool. No, you're not cheating.
First, calculate molecular mass. Okay.
Yeah.
And we do this as if there were parentheses here.
Well, yeah, but it would multiplication works that way anyways.
So.
Order of operations.
So then we go. Does it always give it to me in fractions? I don't know. Is 18 plus 2.16 is 32 equals 63.2.
Nope.
No?
206.
Okay, so what did I do wrong?
Let me see if so I can hovering over you.
No, 13 times 12.
Yeah.
And
Hit plus.
oh, I don't
You don't
equal that out first.
You can just go plus.
Okay, plus 18 times 1 plus 2 times 16.
Oh, it's to use the multiplication, not the.
Sorry.
Yeah. So hit delete. Delete again. And then two.
Mm-hmm.
X.
Yeah, I hit the wrong thing.
Yeah.
16.
Yeah.
To a 6. So what I did before was that I got the answer to this, and then I added it to the answer to this, and then I added it to the answer to that, which should have been the same thing.
Yeah, you somehow didn't put the right numbers together.
Okay.
That's a very normal mistake. It's called a psychomotor skill, so psycho brain motor.
You could just leave it at psycho.
So it's good that you're making the mistake now rather than the test.
Okay. Right. Which is October 9th?
Yeah.
So, okay, so I've got my molecular mass. It's 206.
Yeah.
Now what do I do?
So form the grid. So same idea. 200 milligrams ibuprofen time. So I like that. So 200 milligrams ibuprofen gram to 1,000 milligrams. Then you've got the mole ibuprofen to 206 grams ibuprofen, then 6.02 times 10 to the 23rd molecules to mole ibuprofen.
Okay, so 6.02,
That's Avogadro's number.
Okay, I gotta refresh myself on what that is. 602.
It's right here. So you got.
I know, but I mean just in general.
Yeah.
I don't remember what it is.
Yeah.
I have to refresh myself on that. X, and that's times.
Yeah.
Times, and that's C. Is that 10?
10. Yeah.
10 over 23. Okay.
Okay. Do you know how to put that in your calculator?
IB molecules.
Okay.
So we're going to go. What did we do? We take 6.02 times 10 to the 23rd.
Do you want me to show you?
Yes, please.
Okay. So I'm going to skip 0.2 because 200 divided by 1,000 0.2 divided by 206 times 6.002 and then times 10 you have this 23rd. So you see how I did that?
Yeah.
Here I can do it again.
What what is the
0.2.
formula that you're using?
I'm using this.
But so this is the this is your weight of the tablet, or the
Yeah, molecular mass.
so you multiply. Like if I were to write this down so you can learn it, how do I want to write the formula down?
It's right there.
But I mean in words.
In words?
Molecular mass times.
Okay, the mass. Okay, 200 milligrams ibuprofen.
So mass times
Mass divided by molecular weight.
divided by molecular weight. Okay.
Times Avogadro's number.
Mm-hmm. All right. This helps very much.
Yeah.
Times avocados.
Yeah.
Avocados.
Avocados, yeah.
Number.
Mole,
Okay.
guacamole, yes.
Avocado now. Okay.
Okay.
And this gives me
The number of molecules. But it's the units, so I think you could put more information from that.
okay.
So 0.2 divided by this is how you put in a calculator. 0.2 divided by 206 times 6.02 times 10. And then times the b. Did you see how I did that?
Mm-hmm.
Can you do that now?
Okay, so we're going to go 0.2.
Or 200 divided by 1,000, either one's fine.
0.2. And then we're going to go divided by 206.
Correct.
206
Yep.
times 6.02.
Yeah, that's right. Then times 10.
Times
Oh, no, you don't have to do that.
10.
2, 3.
24.
There you go. And you're going to write from here on out for the rest of the semester.
5.8. So the answer is B.
Yep.
20. Okay. Thank you.
Okay, let me check. So how are you? Okay, so you understand what's going on? Okay. Alright, good. Well, on my way back. Will you put your calculator? It's going to be, it's going to do 200 divided by 1,000. 2 divided by 206 times 6.02. Yeah. Milligrams cancel, grams cancel. Yeah. The idea here is that these units cancel. Because this is the top is multiplication, the bottom is multiplication. Okay, can I go here? Yeah. Okay, let's. So how many seconds are there in here? Okay, you know that 1 year has 365 days in a year. 24 hours in a day, and there are 60 minutes an hour and 60 seconds. So years cancel, days cancel, hours cancel, minutes cancel. Yeah, that's exactly what it is. here, milligrams go away, grams go away, moles goes away, and you won't need to yeah, yeah. Yeah, okay, that's fine. That's not about as much. It's deep. Can you answer some of that? You guys need any help? You guys need any help? You got it? You good? Okay. Awesome. What do you use? This is dimensional analysis. So let's say, so how many seconds in a year? So seconds in a year, you start with 1 year, and then you have 365 days in a year, and then 4 hours a day. And then you have 6 days, an hour, and this years cancel. You multiply it across. The years cancel, the days cancel, the hours cancel, the minutes cancel, and the seconds. 3 dozen eggs. How many eggs do you have? You have 12. So if you have 2 moles of carbon, 12 times 7. So here, looks like that's your goal. You rate these grids, so that way you can show it along the top is multiply and then the bottom is what? Yeah. So I didn't skip this step. I just times. So here, I can prove so you usually get this. That's the molecular weight. So same idea, 2 milligrams, grams, moles, and then here there's your top of this number. You got it? Chemistry's weird. Yes. No, it's do you have any questions? Absolutely, everything in the book would be just a choice. I mean, what you have to do. Oh, I'll assume you know it, but if you don't know it, just tell me. If you don't know nano, that is, it's not good now, it's very easy. What I don't answer is yeah, I don't give answers, I don't give strategy. Like definitions and versions. Okay, the question was, do you have to know that a milligram is 1,000 milligrams in a gram? I mean, if you don't know that and you get to a test and you forget it, or maybe you remembered it and you forget it because you're stressed out in the test, you're allowed to ask that during a test. I don't require you to memorize that. So what do I answer during tests? I'll answer definition questions, conversions, those are all fair game. I will not give answers and I will not give strategy points. Right? So I'm not going to be like, well, have you thought about converting to moles and then multiplying by the molecular weight? You know, like I'm not going to say that during the test. If you ask me how many milligrams in a gram, I'll say 1,000 milligrams in a gram. You know, that kind of stuff. But I won't say, well, you thought about doing it this way. No, that's no strategy points during a test. No coaching in that way. Okay. So everyone's kind of converged that the answer is B. But you probably can get that without doing the problem. So one of the things I'm training you to do as well is when you get a problem in a test, try and think, hey, can I figure this out without even solving the problem? So atoms and molecules are whole numbers only. So 9.7 times 10 to the minus 4, you can't have less than one molecule. There's no such thing. There's these. So chemistry deals with a branch of mathematics called discrete mathematics. So there is no average. I mean, we have these numbers, these flowing numbers, but you can't have half an atom. So I spent a summer. I was an intern at Bath and Body Works in Victoria's Secret. It's a company called Intimate Brands, and I was working on how to make candles, and I was doing calculations on how much time you need to have for each person. Like you're an assembly line. There's like when they have candles, they pour candles into a mold, and then the candle wax, it dips down. You have to pour it again. So if you look at the bottom of a pet candle, a pillar candle, you can peel back the label and you can see where it's been poured twice. So you pour the stuff in the mold, you pour it twice, and you take the candles, and then they do stuff to it. They drill a hole in and they put the wick in, and then they slap the label on, and then they take it down and they put them into boxes and that kind of thing. So I was calculating the amount of time it takes for each step, and when you calculate that out, you get to a point where I need to make 10,000 candles in a day, I need to have 2.3 people at this station. So I need 3 people at that station. So what does a 0.3 person looks like, right? People deal with discrete mathematics, whole numbers. You have to round. You have to deal with whole people. Just like atoms and molecules, you have to deal with whole numbers. You can't have a fraction molecule. You can have a fraction of a mole, but you can't have a fraction of a molecule, so that one's wrong. 206, that's too tiny. 206 is really, really small. And so just by looking at this, you can discount C and D. And you have to pick between A and B. And A is close to a mole, which an ibuprofen, looking at this, and I look at 200 milligrams, I wouldn't think it was a mole because, I mean, with 13 carbons, that's going to be on the order of 200-ish grams right there. So you could guess from this, just looking at 12 times 13 divided by 200 there. You can kind of get to answer B without doing that much math at all. Yeah. Well, I mean, the important thing was the process, right? I want to see you get the process of the stuff. Okay. So assuming just the ibuprofen, how many atoms are there in that 200 milligram tab? So ibuprofen, so 13 plus 18 plus 2, that's 33. So 13 carbons plus 18 oxygens plus 2. In my mind, I look at this, 18 plus 2 is 20, plus 13 is 33. So that's 33. And how many atoms are in this 20 milligrams tab? Well, it's not 33. It's 33 in each molecule. But we have 5.8 times 10 to the 20 molecules, so it's not A either. And we have to choose between C and D. Which one makes more sense? It's probably not Avogadro's number. It's going to be C. Right? Besides 6.02 times 10 to the 23rd, that's a mole. And we already saw, well, you can calculate, that'd be safe enough to calculate out. Besides, I have that in 3 sig figs, and the other one's in 2 sig figs anyways. So it's just 5.8 times 10 to the 20th times 33. So 6 times, so that's 18. So I'm doing my head. 5.8 is close to 6, and 33 is close to 30. So 6 times 30 is 18. So, oh no, wait, 5. I'm sorry, that's 180. Oops. What am I saying? 6 times 30 is 180. So then it's 180 times 10 to 20. So that's 10 to 22. So 1.8 times 10 to 22. So C is the right answer. Questions with this one? Is that too fast? Okay.
Yeah.
I'm getting people that they look at me squinty-eyed. Okay. So C13, 13, H18, O2. So 13 plus 18 plus 2, 33 atoms. So, and then we have 5.8 times 10 to the 20 IV molecules times 33 atoms per IV molecule. IV is ibuprofen. I don't want to spell it ibuprofen each and every time. So how many atoms are in that 200 milligram tablet, excluding the other stuff? We've previously determined there was 5.8 times 10 to the 20 molecules of ibuprofen. Each ibuprofen molecule has 13 carbon atoms, 18 hydrogen atoms, 2 oxygen atoms. So each of these has 33 atoms. So if we have this many molecules, and each one has 33 atoms per molecule, you multiply this out, you get close to 1.8 times 10 to the 22nd. Or I guess it's 1.9 without doing putting in the calculator properly. Is everyone following?
No.
No.
What are you're multiplying the 5.8 times the 33, or what do you?
Yeah. Okay, so I'm trying to think what's a colloquial example. So 20 Big Macs times 550 calories per Big Mac. Right, that's how many calories, in Big Macs I had last year. I never eat a Big Mac. But... Huh? I usually eat the fish sandwich and fries with a big frickin' Coke. Right, if I want to figure out the number of calories in a Big Mac, right, so I'm breaking this Big Mac down into calories. Likewise here, I'm taking these molecules and I'm breaking them down to atoms. And since C13H18O2, 13 plus 18 plus 2 is 33. There are 33 atoms in this molecule. So this many molecules has that times 33 atoms, or 1.9 times 10 to the 22nd atoms.
So you basically just put that over 1 and then multiply.
Yeah.
Thank you.
Yeah. That's dimensional analysis. It's looking at the units. Questions? All right, and I'm probably not going to have time to solve this problem. Well, I could solve it real fast, but then it wouldn't help. We will pick up here on Monday. Hopefully, I will. Did you guys get my email?
Mm-hmm.
Do you guys like getting weekly reminders?
Yes.
Okay. So, okay. I'm just copying it over from the. Do you like the fuzzy animals? Okay. So I'm going to DC tonight. So if you try to email me, I may be a little slow, and hopefully I'm not a zombie on Monday.